not just learning it, but where it is used also you're learning it. Okay. Then after that, mathematical and statistical functions. Now there is an aggregate functions like sum, minimum, maximum, mean, median, standard deviation, as well as what? Variance. And you'll be doing operations according to the access wise operations. Like whenever you talk about array, the array is having access, like it can be 2D or 3D. It is having access 0 and access what here? 1. That is nothing but row and columns, right? And even you will be doing some cumulative operations like cumulative sum and cumulative what? Product. So these are called mathematical and statistical functions. And even this also you do it with some real time. Lot of examples you see it. Okay, a lot of examples you learn as a part of this NumPy. Lot of examples you learn as a part of this NumPy. You learn with some real time use cases. Then after that you are talking about like how to reshape it, joining the arrays like horizontal stack, vertical stacking, and concatenation. Okay. And splitting the arrays by using horizontal split, vertical split, and what is it? Split, right? So these are nothing but array manipulation functions. There are a lot of problems related with the linear equations. Now, all this you learn with some real time. All this you learn with what? Real time use cases. So that is solving the linear equations. And next one is random number generation. And you'll be working with uniform distribution, and you'll be working with normal distribution, and you'll be talking about what is a seed, and all this. Now, shuffling and permutations and combinations. All this you learn as a part of which one? A random number generation. So this is along with some real time use cases, along with some real time use cases, right? हाँ नहीं आया अभी भेजूंगा यार आज भेजूंगा okay. So I'll send today this syllabus also along with the yesterday's notes. Okay. Along with the yesterday's notes, I'll send it. Okay. Understood what you're learning? This is not basics. Even if you join data science and AI, they don't teach all this. Understood? If you join data science and AI, they don't teach all these things. They teach only the things which they require. Okay. They don't teach from basics. Even though if you join data science and artificial intelligence. Okay. Na? So, but NumPy is a core. If you don't know NumPy, because this is a library which is used by all other libraries. All other libraries means pandas depends on which one NumPy. Matplotlib depends on which one NumPy. And if you work with AI libraries like Keras, TensorFlow, all these also depends on which one? NumPy. So NumPy is a core. Means there are so many dependencies. There are so many dependencies on which one? NumPy. You can say NumPy is the heart of this data science and what? Artificial intelligence. And not only that, you'll be learning some advanced, advanced, what do you call it as topics. Now that is structured arrays and masked arrays. Now these are very much useful when you are working with data science and artificial intelligence and broadcasting tricks and memory efficiency. And then you'll be learning vectorization versus loops, right? So then you'll be doing some capstone projects like related with matrix operations and stock and weather data statistics using NumPy and image filtering with what NumPy. So images. So for example, if you want to flip the image, like you want horizontal, vertical, okay, skew, all these operations you can do it by using which one? NumPy array. You'll flip, right? You rotate the image. How you rotate the image? You flip horizontally, you flip what vertically, and you rotate the image some 90 degrees or something. How can you do all these things? By representing image. How you represent image? Generally, what is image? Is a collection of pixels. Image is a collection of bytes. And where you load these bytes and perform the operations in the form of one matrix. And that matrix is nothing but what? Array. Understood? Right? So all these things you'll be learning as a part of your course. Okay, with some real time use cases. Okay, right? Understood this one, all of you. Now, even though not only this, you will be learning how to load the data from files, how to load the data from files, and how to save the NumPy arrays into the hard disk. Because whenever you are talking about objects, where these objects get created in RAM, yes, you create a list where the list is created in RAM. And whatever you store within the RAM or main memory, is it temporary or permanent? Temporary. It's not permanent, right? It is what? Temporary. If you want to store it permanent, where you store it permanent? In the hard disk. You store it permanent where? In the hard disk. Then how to save the NumPy array into what? Hard disk within the file. How to read, how to load the data from file. All this you'll be learning as a part of your course. Understood? Here I'll add it. Saving, okay, saving NumPy array and loading, okay, loading data from file into what is that here? Array. So even I added this because you're learning this. Okay. So there is a lot of things you are learning as a part of this course. So it is not basics you're learning. You're learning what you're learning here in depth. So this is in depth. In depth, what is that? NumPy. Not basics NumPy. It is in depth NumPy. Even if you ask data science people also, they don't teach or all this functionality. They don't teach all this functionality, right? Okay. Is it clearer? This one is clear, right? Okay. Then next is yesterday we started NumPy. We started with introduction to NumPy. Okay. So we'll start with introduction to NumPy. This is the first chapter. So in introduction to NumPy, yes. Kal bola yaar my duration. How many times I should tell duration? Yes. बोल दिया ना? Yes. So introduction to NumPy. You are not there, huh? Okay. A video will give. I'll give video. See that video. So here, yeah, yes, yes. That we'll discuss. But first we started with NumPy. Then I just given content of which one? NumPy. Okay. So now yesterday we started with what is, okay, what is NumPy? Okay, yesterday we started with what is a NumPy. I'll share this syllabus and notes in my Telegram. So I'll share the complete syllabus, NumPy, Pandas, and Matplotlib, right? So in my Telegram, but that is a NumPy content. So fine. Okay, now this is my Telegram ID. Sorry, this is my Telegram ID. You can join in my Telegram. I'll share the syllabus and daily notes. Okay, I'll share the syllabus and daily notes in this Telegram. Okay, right? Okay, now here I'm starting with what is Numpy. What is Numpy? Okay, so yesterday I've just given introduction about what is a library. Yesterday I said about what is a library. We started with what is a library. So this is a module and having NumPy, Pandas and Matplotlib. Yesterday I said what is a library? What is a library? Library is a collection of programs. The library may be one program or collection of programs. And each program in Python is called which one? Module. In Python, a library represented as what? Module. In Python, a library is represented as what? Collection of modules. And this collection of modules is called what here? Package. This collection of modules is called as what here? Package, right? And these libraries can be predefined or it can be what? User defined. The libraries provided by Python or third-party vendors are called which libraries? Predefined libraries. And Python comes with huge number of libraries, and libraries makes it application development what? Easy. So that is nothing but you're not writing the code, you're trying to use what? Existing code. That is called as less coding. For example, a person want to manufacture, suppose a person want to manufacture some mobile. Suppose you started one mobile manufacturing company. Okay, you started one mobile manufacturing company. So in your company, this is your company. For manufacturing mobile, you require raw material. You require lot of things, raw material, right? Then here you don't manufacture anything in your company. What do you do it? You import everything from outside. You import everything from what? Outside. What you are importing from outside, for example, from China you import processor. Okay, from Japan you import which one? From Japan you import which one? Motherboard. Okay, from X country you import which one? Battery. It means are you manufacturing anything in your company? No. You are manufacturing it. You are manufacturing mobile. But mobile parts are manufactured in your company? No. Mobile parts are not manufactured in your company. You are importing all this from what? Different countries. And here you assemble it. Here you do what? Only assemble. It means you are using the components or developing the components, using the components. You are not developing the components. What you are doing, you are using the components which is already developed by somebody else. You are using the components which are already developed by somebody else. And then developing a product or not? Yes. So you are importing. See, the terminology I used here is what? Import. Import means you are using from other places. Here also same thing, right? Here also same thing. You are not developing your own data structures. What you are trying to do, you are trying to use the existing data structures. Okay, now I said what is a data structure is. What is a data structure is? A data structure defines set of rules and regulations for organizing data inside memory. A data structure defines set of rules and regulations for organizing data inside memory. By organizing data, by organizing data using rules and regulations, the complex problems can be solved what here easy. Okay. Now Python provides some predefined data structures called which one? Collections. And these collections are classified into how many here? Three. One is a sequences, sets, and one more is mapping. And how many types of sequences are there? Six, seven. List, tuple, string, range, bytes, and byte array. And how many types of sets are there? Two types, set and one more is frozen set. And there is only one mapping collection, and that is what? Dictionary. I said, the data is never processed. The data is never processed. The data is never processed within the hard disk. The data is never processed within the hard disk. The data has to be processed by storing in what? Memory. Compulsory, the data has to be processed by storing into what? Memory. That means you need to organize the data into memory. For example, image is there. Image. You have an image, right? You have an image. So image, what is the image? Is it image is a collection of data or not? Yes. Whenever you talk about image, you'll say image is a collection of what? Bytes. Image is a collection of bytes. And this image is represented as one matrix. This image is represented as one matrix. It is one matrix. Because image is having a dimensions, right? Image is having a dimension or not? Yes. Image is having a dimension. It is having a width. It is having what? Height. It is having a width. It is having what? Height. That defines the dimension or not? Yes. Now I want to process this image. I want to process this image. For example, in your mobile, you try to flip image vertically and what? Horizontal. How you do that? You just say flip vertical and flip what? Horizontal. But how it is doing it? How it is doing it? Your image is represented as one matrix. Your image is represented as one matrix. This is one matrix which contain number of rows and columns. There's number of rows and columns. Now, when you're saying flip vertical and flip horizontal, you are trying to change what? Axis. You are trying to change what? Axis. Axis 0 to axis 1. Axis 1 to what? Axis 0. Axis 0 to axis 1 and axis 1 to what? Axis 0. You try to do some operations like stretch. You try to do some operations like skew. You try to do some operations like what? Rotate. How it is doing it? All this it is doing it by loading that image into what? Memory. In memory, that image data is represented as one matrix. It is represented as one matrix. And on this matrix, you are doing some operations. On this matrix, you are doing some operations. We'll see with the example. Okay, we'll see with the example so that you can understand how this Numpy is useful. How Numpy is useful. Not only it is used for image processing, it is not only used for image processing, it is also used for doing lot of statistical and mathematical operations. Lot of statistical and mathematical operations when you are working with data science and what? Artificial intelligence. Getting or not? Okay. So there is a lot of usages of this NumPy. Okay. And NumPy is a library. I said no, it is a core library for data science and artificial intelligence. NumPy. What is a NumPy is? NumPy is a library. NumPy is a library and it is which package? Third party library. Means this library is not developed by whom? Python people. This library is developed by which one? Some other third party vendor. Third party vendor. Third party vendor. And NumPy stands for which one? Numerical Python. Numerical Python. The name itself, right? Numerical. So the name itself, you can do some mathematical or statistical operations by using which one? NumPy, NumPy or numerical Python, right? So let us see more on this. What is this NumPy is? Okay. And what is the advantage of using this NumPy is, right? So this is my Telegram. Online students, just try to respond here. Online students, online students, you're there. Okay. Very silent. Yes. Double voice coming. Check your side. Double voice means all are. Isn't my voice is clear, right? Online students, is it voice is clear? Right. Okay. So Venkat Sai, that is from your side. Okay. Right. So NumPy stands for numerical Python, and NumPy is a library and it is a third party library. Now I say no, this is the official website of NumPy. If you see the official website of NumPy, you can switch whenever you want, you switch. No problem. Abhishek. Okay. So this is the official website of NumPy. You can see this is the official website of NumPy, www.numpy.org. This is the official website of NumPy. Okay. So official website of NumPy is okay www.numpy.org. So here you can find complete documentation related with what NumPy. If you want to install the NumPy, you can install the NumPy. And what is the latest release of NumPy? NumPy 2.3. What is the latest release of NumPy? NumPy 2.3. Okay. So now you can see the latest release or the latest version of NumPy is okay. NumPy 2.3. NumPy 2.3. What is the latest version of Python? 3.13 point something, right? But they are about to release 14. They release beta version of Python, that is 3.14. So they are about to release, that you can find out here. They are about to release 14. Okay, don't put in QI, Pradeep. Don't ask the questions in QA. Okay, October 10th. They are about to release one more new version on October 10th. You just open this www.python.org. You can see downloads, and here you have all releases. And in this, you can find what is the version is 3.14, which is pre-release. So this is pre-release means bugs are not fixed. Okay. Now they released and they are planning to release. The first release is in which month? October. October what? 7. See, every month of October they release one new version. And they try to give the support for each version for how many years? 5 years. It means that version you can use and develop the project 5 years. And after 5 years, you switch from one version to another, right? So that is how it is. Now you can see end of life is 2030. What is the end of this life is 2029. What is paper stands for? Python Enhancement Proposal. Python enhancement proposal, it is a document. Python enhancement proposal, it is what? Document. And this document tells what are the changes which has to be done within the version. And it defines the rules and regulations how to write the code. Okay. So that standards are given by which one? PIP. It's nothing but PEP, which is nothing but Python enhancement proposal. Python enhancement proposal means they put all what are the changes they have to do as a part of which one? Language. So they put that as one proposal, not paper, not paper. Paper is different, paper is different. In Python, you find two terms, paper, pepper. Okay, right? Now you are finding two terms. One is paper and one more is a pep. So paper stands for Python. What does pip stands for? Preferred installer program. Preferred installer program. If you want to install any library, if you want to install any library, Python is provided one utility. Python is provided one command. What is the command is pip. So what is pip? Preferred installer program. Preferred installer program. Okay, whichever program you distribute. Generally you don't install modules, you do install only packages. If you want to make a module as installable, then you put that inside what? Package. All right. So pip is used for installing the packages. Okay. And pep is Python enhancement proposal, is a document what it define the changes which are done in the language. What are the changes done within the language? So that is defined in what? Yes, PEP. Just like release notes, right? So these are the differences here. And according to this official documentation here, according to this official documentation, so there is lot of things you can do by using which one? NumPy. There are a lot of things which you can do by using which one? NumPy here. Now, when you see NumPy, yes, it is used in which domain? Scientific domain. It is used in which libraries? Array libraries. Like these are the libraries. These are the libraries here. So many libraries which depends on which one? NumPy. So all these array libraries based on our backbone is which one? NumPy. And not only that, it is used in which one? Data science. So data science, what you are using now, pandas is there. Pandas, which stands for panel data system, or you can say Python data analysis. Some people say Python data analysis. Some people say panel data system, right? So it used by extracting, transforming and loading, and it is used for exploratory data analysis, and it is used for model creation and evaluation, and it is used for generating a dashboards. Even it is used in which one? Data science, and even it is used in what? Machine learning. Machine learning, which is a part of which one? AI. So when you're talking about machine learning, you have a deep learning where you work with what? Images. Even this also uses which one? NumPy. Here, you'll be using scientific pi. You are using TensorFlow. All this uses what? All this uses what? One data structure. All this uses what? A data structure for representing what? Data. But how or which data structure is used for representing data? NumPy. This data structure is used? NumPy, right? And visualization. Even you can do visualization by using which one? NumPy. So NumPy is having his own visualization where you can view the data in the form of what? Graphs. Okay, now you can see now NumPy is essential component in the Python visualization landscape, which includes matplotlib. But what matplotlib uses internally? NumPy. I said no, NumPy is a base. NumPy is what here? Base for all other libraries. Why it is a base for all other libraries? We'll discuss. but it is having only one data structure. Okay, so it is used in scientific domain. It is used in scientific domain. Scientific domain means it contain lot of things. See here, quantum computing, statistical computing, signal processing, image processing, graphs and networks. All this you can do it. Now you can see a lot of things which are related with which domain? Scientific domain. And nearly every scientific working in Python draws on the power of which one? Numpy. Getting on us. So don't think that Numpy means only just numerical, right? It is used for scientification and it is used by other libraries. It is used in data science. It is used in what? Machine learning. It is used in what? Data visualization. All these are the applications of which one? Numpy. Okay, right? So everywhere Numpy is used. Everywhere Numpy is used. Okay, yes. But this is a definition which is given by the Numpy people. This is a definition which is given by the Numpy people. So the fundamental package for scientific computing with what? Python. This is a definition given by Numpy people. It is a package. It is a package for scientific computing with what? Python. Understood? So Numpy is a numerical Python. It is used for which computing? It is used for which computing? Scientific computing. Or I can just write here. So Numpy is a package used, okay, used for or used in different domains. It is used in different domains. It is used in different domains. So you can say these are what? Applications. Okay, these are applications. These are called applications of which one? Numpy. So where Numpy is used? Where Numpy is used? Numpy is used in which one? Scientific. Okay, Numpy is used in what? Scientific. Numpy is used in scientific. Scientific means where in scientific is all this comes under scientific only. Scientific domains. Scientific means what is the scientific here? Quantum computing. What is the scientific here? Statistical computing. What is scientific here? Signal processing. Okay, what is scientific here? Image processing. Okay, image processing. So what is scientific here? It is used in graphs and what? Networks. So I just taken some of them. Okay, geographical processing. Okay, some of them I'm using. Architecture and what? Engineering. And you can see chemistry, geoscience, mathematical analysis. It is used in what? Mathematical analysis. Okay, and it is used in what? Bioinformatics. Okay. So a lot of areas this Numpy is used here. Okay, I've just written some of them. I've written some of them, not all. Some of them, but not all. Some of them, but not all. So it is used in scientific, quantum computing, statistical computing, signal processing, image processing, graphs and networks, geographic processing, architecture and engineering, and mathematical analysis and bioinformatics. And it is also used in, now what is the second application is array libraries. Array libraries. What is array libraries here? Other array libraries. Array libraries means what I mean to tell you is other array libraries. Other array libraries are depends on which one? Numpy. Means other libraries are using which one? Numpy. So there are so many libraries here. Numpy API is a starting point. When libraries are written, Okay, create specialized array types or add capabilities beyond what NumPy provides. See here, all these are array libraries. If you see Dask is there, Dask is nothing but array library only. And this distributed arrays and advanced parallelism for analytics and enabling performance and what scaling. Now all these libraries depends on which one? NumPy. For example, if you take PyTorch, PyTorch is used in which one? Deep learning. And when you're talking about TensorFlow, it is used in what? Machine learning, right? But all these libraries uses internally which one? NumPy. All these libraries provide data structures, but those data structures internally uses what? NumPy. Those data structures internally uses which one? NumPy. Now there is a PyTorch. Okay, there is a Py. I don't take all. Okay, I don't take all. Some of them I'll take. Okay, PyTorch and TensorFlow, tensors, which is useful when you're working with neural networks. So TensorFlow and PyTorch. But there are some more libraries which uses what? NumPy. It means NumPy API. API means what? It defines some set of rules and regulations. See here, what is API? Tell me here, what is API? What is API? Application Programming Interface. Application Programming Interface. It means one application communicate with what? Another application by using one program. And that program you call it as what? API. So what API define? Set of rules and regulations. Now you can say NumPy. What is NumPy now? Numerical Python. Okay, NumPy is a numerical Python and it is a library which is used for doing scientific, and it is also used by other people for building what? Array libraries. It is other people using this NumPy for building what? Array libraries. It means NumPy is providing what? Some set of rules and regulations. Means it is defining what? Or it is giving what? Abstracts. What it is giving? Abstracts. What is abstracts is? You want to develop a project. What you require? You want to develop a project. What you require? Abstracts. Yes or no? What you required? Abstracts. Now, a person want to develop an array library. Suppose you want to develop an array library. How you develop it? How to develop an array library? You should know it. How to develop an array library? How to develop an array library? You should know it.
ଦେଖଉନୁ ଆଡେ ଚିରି ଦଉଛି। କୋଉ ନମ୍ବର ଲେଖା ହେଇଯିବା ପାଇଁ ନମ୍ବର ଲେଖା ହେଇନି। ତାର କଣ ହିସାବ ହେଇଛି ବିଷ୍ଣୁ ଭାଇନାଙ୍କ ରୋଷେଇ ହିସାବ।
So online students can hear, right? Online students,
ଚାନ୍ଦିନୀ କିଏ
online students,
ନମ୍ବର ଲେଖା
yeah. So yeah, lot of problems here. अभी टाइप करा जो है चले गए वर्ड ईयर चले गए है शुभ शुभ बोलो यार है yes. So these are applications of numpy. So numpy is used in so many places, okay, right? And I said numpy, it is a API. Let me see. So this is a API, right? What is numpy is, again, it is a API. What is API define? Set of rules and regulations. What it define here? Abstracts. Abhi, now you want to build a numpy array library. Suppose you want to build one array library with added functionality, which is not provided by which one? Numpy. Then how you build your own array library? What you required? Abstracts. Yes or no? What you required? Abstracts. Kaisa build karna? How to build it? You should know that rules and regulations. Okay, that rules and regulations given by what? Numpy people. That is given by Numpy. Now Numpy itself is what here? API. What it defines? Some rules and regulations for building which are which libraries? Array libraries. For building which libraries? Array libraries. Array libraries. Array is a data structure. Don't think something else, right? Array. What is array? Is a data structure. What is a list? Data structure. What is array? Data structure. What is a set? Data structure. What is array? Data structure. So NumPy provide only one data structure. What is that data structure? Array. NumPy bole to pura depends on which one? Array only. And array is very powerful. Why it is powerful, we'll discuss. Okay. So NumPy provide how many data structures? Only one data structure. What is that? Array. Now whoever want to build array library, then how they build array library? Using what? NumPy. Using what? NumPy. For example, this data science people, they want to build an array library according to their requirement. Then what they do it? They build a library by using which one? NumPy. Using which one? NumPy, right? So NumPy API, it also define some set of rules and regulations, right? So for building which libraries? Array libraries. Clear? Bolo yaar. Okay, it is, yes, it is used for building other array libraries, and it is used for scientific, and it is used in which domain? Data science. It is used in data science. Data science. Okay. So day to day life, you find a lot of data. Okay, you find a lot of data, right? And on that data, you do some, what is science is? Science is nothing but, what do you do in science? What do you do here? What do you do in science? Experiment. You do experiments. Analysis. You do analysis. You do analysis. Experiments, analysis. क्या यार? भूल गया क्या? Huh? So what you are doing? You are trying to do some research on which one? Data. So that you'll get some helpful information. Right? For example, predictions. Yes. Predictions. Prediction. Okay. For example, one example like decision making. If you take a decision making, for example, if you take this Indian Cricket Control Board, BCCI, right? They want to choose one player. How they choose player? They choose player just like that? No. They take past data. Past data. They take past data or not? Yes. How many matches this person has played? How many 50s? What is the strike rate? All this they consider or not? Yes. Based on that, they make a decision whether to select or not to select. Whether to select or not to select. That is a decision, right? But how they are making that decision based on some, how they are making that decision based on that, how they are making the decision based on which one? Data. On data, they are doing some statistical operations or not? Yes. Getting or not? So data science, statistics, yes. Based on Ranji and IPL and ये क्या है? इनो कौन पाकिस्तान वाला है? सईद मुश्ताक. Huh? Yes. Oh, it is one more trophy. Okay, I don't know. Asia Cup. Okay. Trophy performance. Okay. नहीं मालूम उतना ज़्यादा knowledge नहीं है यार. Okay. Yes. For example, if suppose Indian government is there, Indian government want to make a decision. What is the decision? Like whether suppose in COVID time, okay, they want to take some decision whether to continue vaccination or not. How they take the decision based on data? They collect all the data from different cities, different states, cities, villages. Okay, all data they collect and they'll try to analyze it. Till now, how many people are taken vaccination? How many people are taken above age of 50? How many people are taken between 40 and 50? How many people are taken between 20 and what? 30, like that. Based on that, they take a decision whether to continue vaccination or what? Not continue vaccination. That is based on which one? Past data. So decision making. Not only that, for example, if we take a bank, okay, if we take a bank, now fraud detection, or you want to find some defaulters are fraud detection. Fraud detection, how you do that? That is also done by using which one? Past data. Based on, suppose a person is eligible for loan or not, how you decide it? Is it that person is eligible for loan or not? By taking which data? Past data. All this
So,
decision making, you do it by applying some statistical operations, right? So that you can do it by using which one? Data science. Data science is a very big, and data science people even uses what? AI. That is nothing but artificial intelligence here. It is used in array libraries. It is used in what? Data science. It is used in data science. And not only that, it is also used in which one? Machine learning. Okay. So Numpy is used in which one? Machine learning. Machine learning is a subset of which one? Artificial intelligence. It is a subset of which one? Artificial intelligence. Okay, what is artificial intelligence? Applying human intelligence to what? machine. Okay, that you can call it as which one? Artificial intelligence. So how human learn the things with the experience,
Okay.
right? How human learn the things with the experience, how machine will learn the things with the past data. Experience. Even machine also learn based on which one? Experience. Even human also learn the things based on what? Experience. Ring or not? Suppose experience are based on the patterns. Based on the experience are based on what? Patterns. For example, there is a x. Okay, there is a x and there is a y. Suppose x is a 2, then y value is a 4. If x is a 4, y value is what? Uh, okay, now y is what here? 8. If the if x is a 3, y value is a 9. Okay. And if x is a 4, y value is what here? 16. If x is a y, 5, what is the y value? 25. How you said it is 25? Based on which one? Pattern. Based on which one? Pattern. So how machine learn the things based on the patterns?
Pattern.
Based on the patterns. Based on the patterns. Okay, now what is the pattern you form? X square. What is the pattern you form? X square. Based on that pattern, immediately you said the result or not? Yes. So always the machine learn the things, but based on what? Patterns. So that is called as machine learning. Machine learning. Suppose when you're typing hello, how are you? Okay, hello. Then you have a Google Assistant. Immediately it will show you the next word or not? Yes. So that is a recommendation. That is a recommendation. Yes, that is a recommendation. But how it is saying that? Based on the experience or based on the pattern, right? So machine learning is very big, and it is also process the data by storing or representing data in what? Numpy arrays. Numpy arrays. It is used in data science. It is used in what? Machine learning, and it is used in visualization, data visualization, data visualization. So a lot of things you can do it by using what? Numpy arrays. Is it clearer? So what are the NumPy applications is it is used in what? Scientific. It is used for building what? Array libraries. It is used in what? Data science. It is used in what? Machine learning. Machine learning or artificial intelligence, image processing and all the things. And it is used in what? Data visualization. It is used in data visualization, right? So all these are the applications of which one? NumPy. NumPy arrays. So NumPy provides a powerful data structure. It will provide one powerful data structure called which one? Array. It will provide one powerful data structure called array. So those who are in C, C++, Java, they'll be knowing it what is a array is. But those who are pure Python, those who are pure Python, I don't think so. You know what is a arrays, right? So, but those who know already C or C++, they'll be using a term called which one? Array. But in Python, you know the term called which one?
ମସଲା ତ ଗୋଟିଏ
List.
କରିକି ସାଧା
But
କାଢିଦବ ତାକୁ
always
ତାପରେ
the
ଆଇଁଷ
people
ପକେଇବ।
compare list with what? Array. So list is a sequential and array is also what? Sequential. List is a sequential data structure and array is also what? Sequential data structure or linear data structure. In list also you store data. In array also you store data. In list how the data is stored in? Linear means sequential, and in array also how the data is stored in? Sequential. But can you matrix? Is it list to provide all array operations? No. List cannot provide array operation. Means is it list is having dimensions? Tell me, is it list is having a dimensions? No. Array is having what? Dimension. 1 dimension, 2 dimension, 3 dimension, n dimension. It is having n dimension, n dimensions. Getting on not? So can you do all array operations in list? No, you cannot do it. List is a list. Array is array only. List is not an array. List is, you can use a list as a matrix, but you cannot say it as a matrix. Whenever you are saying it is a matrix, the matrix is having certain characteristics. Whenever you are talking about matrix, it is having certain characteristics. Is it those properties are provided by list? No. Those operations or those properties are not provided by what? List. Getting or not? What do you say here? Suppose you want to convert one image from color to grayscale. How you convert? You go for original image. Original image is one matrix and mask image is what? Another matrix. Where you convert color image to what? Grayscale. Masking. That is done by using which one? Masking. But how you are doing all this? By representing data as what? Array only. It's very powerful. Don't think that array means only rows and columns. But lot of things you can do it by representing data as rows and columns. Already you learn in mathematics, right? Okay, matrix and matrix operations. But now that you are implementing in real time. Those things you are implementing in real time. There you learn only what is a rank, what is determinant, what is inverse. Okay, all this you learn in your school, but you learn only. But are you learn any applications? No. Where it is used, you don't learn. You learn only what is that rank is, what is determinant, what is inverse is, okay, what is transpose is. Okay, you know what is transpose means, you'll say rows to columns, columns to rows. Khatam. Marks आ जाते school में. But how it is used, where it is used, will you learn in school? No, you don't learn in school, right? But now you implement that. You implement that. You learn that in detail. That you learn in detail. Okay, what will happen if you do? We'll see with the applications, don't worry. So NumPy provides a powerful data structure. Sorry. NumPy provides one powerful data structure called which one? Array. Understood? So, right. Then what is the advantage of NumPy arrays? Why all people are using NumPy array only? Why data science uses NumPy array only? Why machine learning libraries uses NumPy array only? All other array libraries are built using what? NumPy array only. Why it is so popular? Why it is so popular? What is the advantage? What is the advantage? Okay. What is the advantage of NumPy? NumPy what? Array. What is the advantage of NumPy? Array. So this comparison is between NumPy array and what? List. This comparison is between the NumPy array and what? List. This comparison is between the NumPy array and what? List. Okay. Yes. Okay, anyway, we'll see this. Not today here. So now today I started a little bit late, but tomorrow we'll start on the time. Okay, na? Yes. Tomorrow onwards I'll start on the time and come by time. We'll have up to because 9 o'clock have a class. So okay, right? So come on time, we'll have on time. Okay, na? So tomorrow I'll tell you what is the advantage of NumPy, and don't miss the introduction classes. Because somebody asks what is NumPy? Somebody asks you, sir, what are you doing? You'll say, I'm learning NumPy. Then he'll ask, what is NumPy? What is NumPy? Library. What is NumPy? Library. NumPy stands for numerical Python. Is a library for doing which computation? Scientific computation. It is used for what? Scientific. It is used for what? Building array libraries. It is used in what? Data science. Data science, data analytics, business analytics, right? It is used in what? Machine learning. It is used in what? Data visualization. All these are the operations of which one? NumPy. Okay, right? So tomorrow we'll discuss about what is the advantage of NumPy array. But this advantage is comparing with what? Which is the data structure? Listed data structure. Okay, na? So you'll be knowing it exactly what is the meaning of it. Now just I'll upload these notes in my Telegram. This is my Telegram. So what is this? Code with suggestion. Just join in. So today compulsory I'll upload it. Right? Thank you. We'll see tomorrow. Tomorrow class is there. Okay, na? Right.